So thanks very much for coming down. Oh good, it works, and I don't have to stand back there. So basically, I sort of describe myself, and I'm sure a lot of you here describe yourselves well. You may not describe yourselves in the past this way, but maybe in the future you will. I do data stuff. I'm a data stuff person. Okay, whatever you want to do with your data, I can help you do it. So, so that's pretty much what I do. And I just want to, so that you don't have to get too settled in and you can leave if you want to. I'm not teaching anybody how to do canonical modeling today, okay? It's a 50-minute presentation, and all we have time to do is talk about what it is and why you might want to do it. But okay, if you expected to come here and learn how to do it, unfortunately, we don't have time, so we'd have to request a tutorial. So maybe you could write that down as a suggestion, canonical modeling, how to do it. That might be a really good session for a tutorial or workshop for next time. But so I don't want you to feel disappointed, okay? We're not doing how to do canonical modeling today. So I hope you don't get too depressed about that. But now, so why this came up for me was kind of for a number of reasons, but what started with was that we sold an engagement, a data governance engagement, and one of the deliverables was a canonical model, okay? And my colleague who actually, created this plan engagement, and the client had two definitions of what a canonical model were. And so, there was this little disagreement about it. It didn't really cause a big problem, but I looked up canonical modeling in Wikipedia, and interestingly enough, Wikipedia on the one page had both definitions of canonical modeling. Am I blocking you guys? Because I can go stand over here. So, okay. You could see, right? So they had both definitions of canonical modeling in terms of the client and my colleague in terms of this. But basically, canonical comes from the idea of a canon, right, or the rule. And the way we use canonical, I don't know who really uses canonical in English, but the way it's come to mean is more like a standard, okay? So, or the typical, the term that Mike Ferguson was using yesterday in data virtualization was a common model. Okay, so that's it. All right, so that's what a canonical model means is a common model. So you can all leave. We're done. So it's the idea that it provides the simplest form to create a standard common view, okay? So you can see in data governance, which is what the engagement was that I was working on, okay? What we were talking about was a common view of the business terms of the organization, okay? Which is one of the standard deliverables that in a data governance engagement is that you help them to create these common definitions of their major business terms in their organization, and creating a common definition is hard. So that's that definition of it. But where it's also used and where I'm also engaged in, and so I actually sort of initially assumed that what the deliverable meant was in data integration and messaging, right? It's the central hub of all your messaging and your data integration movement. It's the definition of all the data in your organization that has to move through this central hub. So we'll go through that. So here's here's where, so you can kind of see where those two definitions are sort of the same definition. So in one case, you're talking about common business terms and defining them. In another case, you're talking about creating a central model for your organization of all the things in your organization so that's going to pass through. And Wikipedia had both definitions just kind of right together there on the same page, and they weren't saying one is a set of common business terms and definitions, and two is a central hub of messaging, for messaging. So you know, my colleague wasn't the only person who was confused about it. So if you're doing an enterprise integration strategy, one of the things you will talk about is a hub and spoke architecture, and there's the hub. So you need a canonical model for the hub in your hub and spoke architecture, and that's the second definition of canonical model. And the canonical business model is a common set of business terms used by an organization. And you know, anybody here have data governance activities happening at their organizations, or that they're consulting? You know, so one of the first things that we do is we try to help to create this set of common business terms and definitions, because some of the main metrics for the organization can often get really confused because people are using the same term to have different meanings. So, for example, how many customers do we have is frequently a problem because different parts of the organization, or even different people within the same parts of the organization, are defining the word customer to mean different things. I mean, certainly if you talk to your marketing and sales organizations, they're going to include prospects in it. This is the traditional explanation of this. They're going to include prospects in the count of customers, whereas an operational part of the organization is going to say, no, it's only people with accounts. Okay, it's people we've already sold to and we have accounts set up for. Those are our customers. So counting customers is the easy one because everybody has this problem. Different parts of your organization, I bet, are calling a customer to have different meanings. Okay, and so this is a really important, just very basic problem that every organization has, and unless you solve this problem, there's no report that's going to be right for everybody, because the metric is going to say number of customers, and what were they counting, right? What's the definition of that metric? So this is a very basic problem. And we do canonical modeling, i.e. we identify the business terms in different domains, and then we define them, and we try to create definitions that the entire enterprise can agree on. And if you need a definition, a special definition, then you create a special definition for that part of the organization or that subsidy, or whatever is necessary. But you qualify the definition. So you'll say, a marketing customer is, okay, or a prospective customer is. That's what that we do. It's a very basic part of data governance. So here, as an example, this is in the address domain. Everybody has an address. Well, address is a kind of a cross-domain kind of domain, and these are a bunch of the business terms that we define in this domain. And this is just address. So, I didn't really think this was something I had to worry about secrecy or anything. I think you all know, that these are the kinds of things that you need to define for the organization. Okay, now message modeling is something a little bit different. So traditionally, when we want to pass information from one system to another system, okay, we, let's say, create a file out of system A, and we move it over to wherever system B is located, and then we load it into system B. And then, if have to get data going back. We do it the other way. And maybe you eliminate the actual files and you're just passing the data back and forth, okay? But the way that system A is looking at data and the way that system B is looking at data are two different things. And so we use transformation of the data and ETLs and kind of interesting points like that. But there's a mathematical problem with this that in terms of portfolio management, in terms of managing the computer systems in your organization, okay? And that is that if that's the way you build interfaces in your organization, you will very quickly have a problem of complexity so great that it cannot be managed by anyone, okay? At a very small number of applications. So, and this is like, you know, the biggest improvement for portfolio management that I can suggest. I'm actually writing a book for Morgan Kaufman, and this is one of the things in terms of hub and spoke architecture, okay? If you try to do point-to-point integration in your organization, if you have 5 systems and all of them need to pass data back and forth between each other, okay, you will have 10 interactions that you need to build, okay, and basically the formula for that is it's n minus 1 times n divided by 2, okay, so which is kind of n minus 1 squared divided by 2. So you know you are that is an exponential problem, okay? So as the number of applications in your application portfolio grows, the number of interfaces grows exponentially. That's why very quickly it becomes insurmountable. So at 100 systems, you have 5,000 interfaces. At 1,000 systems, I believe it's slightly less than 500,000 interfaces. Okay, that's 1,000 systems. That's maybe a mid-sized organization, maybe a small mid-sized organization. Okay, that's not many. So it quickly becomes an insurmountable problem. And even on 5 systems, you can see this is a lot of complexity, right? I mean, 5 systems is nothing. I think I have 5 systems running on my PC at home, to do my personal finance information. So the solution to this is a hub and spoke type of architecture. If instead of having every system interface with every other system, and you don't necessarily have to do that, you simply define a hub to your interfaces and you say, okay, I will have every system interface just with the hub. Then when I add an additional system to my organization, I don't have to interface with the n existing systems in the organization. I only have to interface with one system, the hub. So it makes the problem, instead of the problem being exponential in terms of interfaces, it makes it linear, which is a significantly different type of complexity problem. Is everybody cool on this at this point, right? But what I did was I added one new system, and that's that one, okay? And that system has to have a definition of all the data in the organization. Now, I'm not storing it all there. It's not a data warehouse, okay? But every interface is going to go through that hub. And so I need a definition of all the data that I'm going to want to share among the organization in that hub. And that needs a canonical model. Okay? And so, in the data integration world, in the ETL world, that's what a canonical model is. It's the definition of that hub. And then, in terms of transforming your data, right, you only need to define the transformations of the data from your system, from any system in the organization to the hub, and from the hub back to any system. So this is a very complex data modeling problem. Okay? Yes?
Question out of ignorance.
Yeah.
So why not, if I have a canonical model defined?
Well, therein lies the rub, but go on, yeah.
Right. So why have that system in the middle when I can do direct interaction between the various systems by just having canonical model?
Well, so the question was, if you have the canonical model, then why not just do the interactions between the systems, right? Okay, so there's an implication that you're going to change the systems to be equal to the canonical model?
Yeah, the response from the system is going to be in conformity with the canonical model.
Okay, so why not? So the response from the systems has to conform to the canonical model. Yes. So, but in effect, that's what you just did. Was you have the hub in the middle because the systems will change to the format of the canonical model. So yeah, this doesn't necessarily have to actually be a system. It's just a model. It's a format that you're going to have to change into and out of from each system.
So just one other point. So with this diagram, what you're saying is the response from each of the systems is going to be the traditional response, and the transformation happens in the center, the blue box.
So where physically the transformation might happen has to do with what your integration solution is, so probably kind of happens in the ESB or the orchestration software or something like that. But logically, and entirely logically, to me, right, it's this central hub that it's going through, and physically that might not be true. Yes?
Question, perhaps you're going to address this, but suppose, and I'm thinking back to, you said your slide said canonical is the simplest form. Okay? Now suppose I want to share citizen information between all these different agencies. Can I have the whole elaborate citizen canonical model, and agencies which only want this part or that part can
So if I want to share citizenship information between these different agencies, do I have to share the whole definition of citizen between these different agencies? And I actually will address that in a minute. And that's a really good kind of real life problem, right? Because you want to sort of define these messages to be a certain length, balance the length of the messages to reality, but also you don't want to be passing information that's not needed to these different applications. Yes, another question.
What's the difference between your canonical data model and the enterprise data model?
Oh my goodness, do I have like something really special? Because so everybody likes Swedish fish, right? Okay, what's the difference between the canonical data model and the enterprise data model? So I hope nothing, right? That's what the enterprise data model really should be, is this canonical model that can be used, for this. Now the thing is here, okay, this canonical data model, it's not a, the enterprise data model is more of a conceptual concept, pardon the expression. It's more of a conceptual concept, and this canonical model is a physical concept. Okay, we're talking about an implementation level model here. All right, so that, if anything, that should be the only difference. I mean, the problem that I have with enterprise data models is that sometimes they get into these levels of abstraction that aren't real. But so it's like, well, what's a party? I mean, like, I've never heard a business person who hasn't been taught modeling use the term, well, except if they were talking about events or something. But
If you reach the point where you're doing transactional MDM, real time, that is the canonical model physically instantiated?
Well, so transactional MDM, so is the MDM hub the same thing as the canonical model, right? No, the MDM hub isn't the same thing as the canonical model because the MDM hub is probably persistent data. It's probably a big database of data, although it could be implemented as a logical concept, in which case it is. But the canonical data model is data passing through it. So there's nothing ever stays there. It just goes by. Okay. It's like a translator, right? But it's the thing that you have to translate it into. It's the common language that everything has to be translated into, although it doesn't need to persist per se. Lots of questions. Oh my gosh.
The canonical model just doesn't restrict itself to master data, right? It goes beyond master data.
Right. The canonical model is going to have to deal with anything that you want to pass between systems. So it's clearly not just you certainly.
So the canonical model, does it care at all about the payload, or it's simply a way for two systems to know that they're talking about the same semantic regardless of the actual transmitting the payload?
So, does the canonical model care about the payload? Well, the payload issues, maybe performance issues and things like that, but you don't want candy. She'll eat your candy for you, okay? The canonical model is, but anyway, because I say, the canonical model to me, it's not a logical concept, it's not a conceptual model, this is an implementation model, so yes, you do care about the payload, I believe, okay? Now, I'm an operations person, what can I say? But I believe it does. So there was a couple questions, yes?
Yeah, sometimes it's politically or technically or conceptually difficult to have a single hub. You want to modularize it. You might have kind of clusters of hubs. So you
Okay.
Not the signal picture, but something between n squared and 1.
Right. It's
So how do you deal with these clustering of hubs?
clustering of hubs. Well, then the hubs have to talk to one another, okay? But I don't believe anyway in ripping down what you have because it all has to be the same technology, right? So, it's like, build on success. If you've got hubs that are working, build on that, right? So don't start ripping down solutions just because you feel they all have to be the same technology.
You're talking about going forward and you're designing the hubs and there's different ways to look at the world.
There are definitely, and so no, it doesn't have to be one single hub. It can be regional hubs, multiple hubs, whatever works. Okay, but this is the concept, and we're actually sorry, we've totally got off the topic here. Okay, because the point was, what's the canonical model? All right, and we've gotten into an area that I really like, which is the whole data integration, real-time data integration. But anyway, the thing is that the canonical model is this hub and spoke. It allows this hub and spoke solution to happen. And if you don't have a canonical model, this becomes a lot less efficient. Okay, and let me tell you, if you have, there's a big difference between something on the, you have 1,000 systems, and there's a big difference between managing something along the order of magnitude of 1,000 interfaces from something on the order of magnitude of 500,000 interfaces. Okay, so it doesn't have to be an all or nothing thing. You can solve this problem in one part, and there's other things that are meant to partially solve this problem. Data warehouses partially solve this problem of of the number of interfaces, right? Because it's like, all right, all these different systems want to, or people want to use this data, so we'll just like put all this data into this hub, and then they can use it. MDM partially helps to solve the problem. All these different people want to use this data instead of all systems having to pass data to all systems. They all come and get it in a certain central place. So, it's not an all or nothing thing, but this really brings down the levels of complexity tremendously in terms of this problem. And that's what the canonical model is, getting back to actually the point. So, so you have this one additional hub. I'm sorry, was there anything else that? Okay.
I want to see where you go, because we may be asking questions about where you're going.
I'm not going to like solve anybody's problems. You know, the point of this, all I have time to get into here, right, is, you know, what is a canonical model and why do we use it? Okay, so I'm not going to get, you know, and I'm going to try to not get all involved in data integration issues too.
The canonical model doesn't store any persistent data. Do you ever store that somewhere else? I mean, you said data passes through it, but we don't store persistent data.
So
then the question is, do you store it, and if so, where do you store it?
So, all right, so the question is, if you're never going to persist the data in the hub, do you ever actually store those messages, and where do you do that? Well, there's Hadoop. I mean, that's a big data problem, okay? Because that's a lot of data. And I actually worked at Citibank at a point where they said they were going to store all of that, okay? And that's just a huge problem. So that's a big data problem. It certainly is actually solvable. You can store all those messages if you want to. And you know, and in practice, right, there's probably persisting somewhere on the ESB and log and stuff like that. But yes, John. Oops.
I felt that your square indicated that it wasn't necessarily a database, but that it actually could be a process or a system reference process. But I did notice the squares in the other areas, and I wondered if that canonical model doesn't require some sort of key or some sort of identifier underneath this that allows you to find your way in the middle.
So the question is, does the canonical model require some sort of key to the messages that are coming in and out of this in order to find your way? So, well, you know, what finds your way is, you know, this is actually implemented usually in an enterprise service bus that handles the orchestration of the requests and the subscriptions and the responses to the different systems. So yes, you know, the messages have all kinds of, you know, interesting things in their headers and stuff that keeps track of that. But what I was showing, whoopsie, what I was actually showing here, right, is that I'm a big believer that if possible, you should be having applications talk to applications, not directly to the underlying data stores, okay? So that's kind of the difference between enterprise application integration and enterprise information integration, okay? And I think that if possible, enterprise application integration is the way you should go, as opposed to directly talking to those data stores. But that's.
What does the actual hub look like?
Shh.
Okay,
Okay, what the hub, you know, what the hub looks like is it looks like your enterprise data model. It looks like your XML message definitions. It looks like your object data services. So it's an implementation model. It looks like your relational database, you know, design. Okay, but it's a design principle, not an implementation, right? So you use whatever tools that you're using to solve the integration problem, and that's where you design.
I came up with this nice, you know, paper of my enterprise data model.
Okay.
Now, how do I
Well, it depends, what you're, how you're implementing so how do you turn your enterprise data model into something useful? Well, it you have to have a data. Yeah, right. Well, you have to have a data integration strategy and then, a data integration implementation, and it's going to be defined in whatever you've defined your data integration implementation in. Like XML, for example. I know at one point I used to say, yes, do you like Swedish fish? I used to say, yes, do you like Swedish fish? And at one point I used to say, well, of course this is going to be in XML, but then I've found, well, it's actually not always in XML. In fact, I've seen more cases where it's not in XML, so I don't say that anymore. Well, I'll give you a couple in a second, so that's good.
Let's let her move on.
And April, we've actually implemented this, so, I mean.
Well, hopefully a lot of people have, right? I mean. Yeah. Yeah, I mean, hopefully a lot of people have implemented this, right? I mean, yes.
So one thing we're doing with canonical models is we're creating joint views from our reference data models, our customer master data model, our product master data model. We create joint views in Irwin. We publish those views or extract them as XML schema definitions. Those XML schema definitions are picked up by our developers and used to write web services that go through our iWay EAI integration hub and then talk from application to application, as we said, without talking directly to the underlying data source.
Well, that has to be kind of the de facto standard. I mean, so you've defined the canonical model, the hub in Irwin, and then the output from that is an XML model, and then you translate that into web services, and that's exactly that's probably what it looks like, right, for anybody. But there's other ways that it can look like. Yes.
But you're saying you're feeding that from all your individual data models, and that assumes that they're all defining things the same. If you don't have customer information in one and customer information in another, then it's quite different.
No, we're generating this out of our reference data models. So we have a customer reference,
Can we
single
move on?
customer reference data model.
Can we move on?
Okay.
I'd like to hear what April has to say.
Well, I'd like to hear what he has to say, but that's okay. We could talk about this for a long time, right? I mean, this is good. Okay, so. Oh, David, what time do you start drinking? What time is it? Do I have until 4:10? Is that when this is supposed to be over? Okay. All right. So this is just this is a little bit kind of objecty. Okay. So you have types. You have types of contact information. So you have an inheritance concept of types, and then within the types, you have components or breaking down an email address into its component parts. And this is just kind of a type of approach to, let's say, to modeling that you might do, right? You can do it relational. This is kind of an object type of breakdown of in terms of defining your stuff. So, and if you're implementing so you could do this in a relational modeling tool, or in a UML modeling tool, or in XML modeling tool. It sort of doesn't matter. I think that you should use the modeling tool that's relevant to your implementation, because that's most useful. Okay, I mean, that's my opinion. So recently, what's actually kind of come up for me was the fact that actually defining a canonical model is really important for object development in web services, especially so defining data services, reusable data services is a very big, important step in terms of trying to get reuse out of your object models, right? Out of your services. And isn't that's like the holy grail of SOA is reuse, right? But if you don't have reusable data services, you're just going to really be a mess. Well, for all kinds of reasons. Anybody need me to go through what those reasons would be? So anyway, so I came across this interesting article. I actually had this experience where this is true, where it was like, if we weren't defining data services in a canonical way, it was just turning into a real mess. And the client actually asked us to explain to the programmers why they needed to approach this in more of a reuse, using a canonical model, common definitions for the data structures way. And I found this article from Forrester Research that said that it seems like in conferences about canonical modeling, it seems like more of the users of canonical modeling now are using it for reusable object development and services than they are for the whole data integration hub and spoke type of solution. So this is actually a really big area of use for canonical modeling. It's achieving that reuse out of your objects, out of your data services that's always promised in that area. Okay. So just a couple little pieces of advice, all right? Using industry standards, always a good idea. But industry standards tend to be about passing information between organizations as opposed to passing information within your organization, okay? And the way that canonical model is going to look is a little bit different because of that. Not like a huge amount. I was trying today to think of an example of this, okay? Many years in the financial services industry, and we use Swift messaging for passing messages between banks, okay? But then I was thinking, in securities processing, you have balances, people's balances, or either their securities balance or let's say their checking balance or savings balance. You have the balance, and you have the transactions, right? And there really aren't Swift messages for the balances, but we frequently have to pass balance information between systems, right? In order to check what someone's balance is and then update their balance. And there's, reports or statements in Swift messages, but not really passing people's balances. I can't think of one anyway. So that's the thing. So industry standards, good place to start, but you probably need to build on top of that in terms of getting your whole organizational model. And the enterprise data model, that's what it should be. Your canonical model should be your enterprise data model instantiated. Top-down modeling, yes, I absolutely. Domain, design, coming down, starting with master data, always a good place to start. But if you try to do it one layer at a time, I just don't really believe that you're going to end up with something useful. So I kind of believe in tops down, bottoms up modeling. So actually, you have a problem you need to solve. You have an interface you need to build. We'll build the interface. And then add to your top-down model, and then build the next interface and add to your top-down model. So solve real problems and build real interfaces or real objects. Don't try to do it, one layer of the entire organization that takes a year, and then the next layer of the, and then you'll retire, and and it'll just be shelfware. What did I have to say about meta modeling? I have no idea. So like I'm saying, you're trying to balance practical use with a overall design. Okay, so one place where it's like they built the logical model and then they stopped. It's like, well, it doesn't on its own really have a whole lot of value. You actually have to use it for something, even if it's just to have conversations, I suppose. But in this sense, this canonical modeling for object reuse and for hub and spoke architecture, these are things that really need to be implemented. And there's a lot of governance around this. Okay. As in with everything, just this is the sort of fine print on the there's a lot of governance. This doesn't happen by itself. You need to do design patterns and standards, and then after the fact a registry of reusable objects or whatever you're building to actually be able to get this done, and training and communications and all those things. So just have to say that. It's hard. How do you reward reuse, right? I don't know. How do you discourage single use? I mean, there's ways, but it's very hard. Reuse is hard. Anybody? Well, maybe somebody will talk about reuse sometimes. How they were successful at making reuse happen. Yeah. And just kind of a little a little side note. I think this is practically my last slide. So then we can have 5 minutes of questions. Which is how is canonical modeling like relational modeling? Canonical modeling is a little bit more hierarchical. I believe, XML is a little bit more hierarchical to me than relational modeling. And yet, when I look at the real implementations, somehow the canonical modeling is maybe more relational. Because like what I always see for mailing addresses, right, is that you get, you have address line 1, address line 2, address line 3, instead of, a relationship to 1 to many address lines. It's always implemented with something like this. And, in XML, you don't have to do it that way. You can just give as many address lines as there really is. So does that mean that the XML model is actually more relational than the denormalized relational model? It seems like yes. Sorry, George.
Each XML message is a hierarchical view of part of a relational model. That's good.
Okay.
So you can take a relational model and generate all sorts of views from it. So you could have orders by customer, or customers, or products by order, whatever makes sense.
Right.
For that particular message, but it can all come from what looks like a relational model.
Now, that's true. There's an interaction. Yes.
Interesting you said that, because my feeling is, or my experience is the opposite.
Okay.
That canonical modeling is less hierarchical, because what you're joining is hierarchical structures very frequently, or structures that are committing to hierarchies. You have to get rid of that in the canonical. You have to make it very flexible as to what owns what and get out of hierarchies, so that you can project that onto the ends. So the hierarchies come as you project it into the various systems, and the middle should be fluid.
So maybe
More
canonical modeling.
more like a linked data type of
Right.
approach. Things are just connected.
So canonical modeling was really more relational than relational modeling
Yeah.
in some ways, right? Okay, yes?
I'm in the financial
Okay.
There's, a number of industry standards for this kind of message modeling. And you mentioned abstraction. So a lot of times these industry standards have high abstraction levels, right? They'll have a party in there.
Yeah.
And if you use
We all have
that
parties.
industry standard, you can't extract from that because it would cost, you'd have to rework so much.
So all right.
You
So
said it
so levels of abstraction in an industry model, right? And so what do you do with that? So is that what you're saying, or?
Yeah, how would you implement it, like a party? Would you have separate customer, employee, suspect? Or would you?
Okay,
And
so
does it align to the relationship?
I'll answer that one because it's an easy answer. How do you implement party? So which do you want?
Or chocolate always.
Oh, chocolate. Okay. So how do you implement party in a relational database is the answer. Okay? Right? It's the way it's the same answer. All right? So it's like you can either implement each type of party as a separate table, or you can implement a party in general, or and in object modeling you would you'd have inheritance, so you'd have a party table, and then you'd have inheritance for the thing, for people and organizations would have inheritance of the common stuff, and then the things that are specific to a people and to an organization. So that's an easy answer, but because the answer is the same, it's like at some point you have to implement that level of abstraction, right? And it's the same answer. Well, how do you implement that level of abstraction?
So you're contextualizing it as you implement it, is what you're...
Am I contextualizing it as I'm implementing it? Well, choices have to be made for implementation. So it's this.
Context.
It's the same choices that you make for implementing it in a relational database. I mean, different tools allow you to do different things, or different technologies. So here's this question. Here's this thing about the sizes of these. So, current one I'm working on, right? Client has like 5,000 attributes. Okay. So I'm not going to pass to anybody who wants client information 5,000 attributes, but you do what they're calling topics within the client, which would be the attributes or the fields that are relevant to a particular kind of thing that would need to be done, okay, or that probably a certain kind of application would probably be interested in these attributes about the client and not these other attributes about the client. So you break it down into sort of subgroups of topics. I'm sure there's a better definition to that than topic. Yes?
So ultimately, does Canonical model, at the end of the day, do you have a mapping to a relational database, a attribute somewhere, so a database element? Where's the mapping is being kept?
So where is the mapping kept? All right, canonical model does not necessarily have a mapping to a relational database. It depends on what the systems are that you're talking to. So if you have to talk to, if one of the applications that you're connecting has relational databases, potentially you're mapping to those relational databases. But what's preferable is that you're talking to the API of the application, not to the relational database. So it depends on what you have available in terms of the application you're talking to. Probably at some point you are talking to a relational database because it doesn't have an API. But where is the mapping? Well, that's in the orchestration, enterprise service bus orchestration software, and there's a repository, and that's where the mapping is for doing that. Yeah? Yes?
Can I get to show the hub and spoke diagram again?
The good one or the bad one?
That one. There's semantics in each one of them. And the semantics aren't always going to be the same. So I'm presuming that the semantics in your canonical model is going to be the superset of all the semantics in the systems on the outside?
Yeah, so basically the semantics in the canonical model, assuming it's the superset of the semantics on the outside, makes sense.
Okay, so what that then leaves is that when you're translating from one of those into the canonical model, there's going to be some things for which you don't have any semantics for. So it'll either have to be optional or omitted or whatever. And then if you're translating that into some of other systems, the next leg, there will be semantics that that system expects but can't get because it wasn't in the original. You just have this mismatch of semantics.
Well,
as
you
you're moving through one to the other.
right. I mean, the users of the canonical model are the applications you're trying to integrate.
Yep.
So if one application needs some information but the canonical model doesn't have that information, then you have to change the canonical model to support that need and identify where you are going to be able to get that information from. Yes. Sorry. Yes?
Well, I was just going to make a comment about the superset philosophy and when information is needed by one system and it's not in the canonical data model.
Mm-hmm.
Well, we actually have gone through this exercise. We're in the middle of it, creating a number of these data services using a canonical model. And what we did, it's more like, rather than a superset, I would call it almost a least common denominator approach. You have to design the canonical messages to have data that is of interest to all systems.
Okay,
And then if there's
let me interrupt you because I don't agree. Okay?
agree?
No, least common denominator isn't going to solve this problem.
That's right.
It's a superset, not a subset, not a common subset. Because you need to solve the problem of all the full problem of the integration, not just what comes together.
I may have not stated that correctly.
Okay.
We have to take common requirements and meet the common requirements. And this is how we did it. So you may disagree and we may have done it in a way that
A different way?
isn't correct, a different approach. But what we also did is we said, well, if this system, this claim system, is only using this one piece of information, then we might create a smaller message that is specific to a claims-related view of the data. So
Yes. So yeah, you might create messages that are only used by one application. Okay, I could certainly see that that's the case. However, if only one application needs information, then it doesn't have to be shared with anybody else. Then you don't have to put it in the canonical model. But if you need to pass information between systems, it has to be the full set of requirements for that integration.
yes, that's correct.
Okay, so kind of a nebulous topic, but I really enjoyed the questions, and thank you very much. And this is my contact information if anybody's interested in.